Do you manufacture playing cards? Because if so, I hope those decks have more than 53 cards in them. Otherwise, you're going to owe a tax to the IRS. That's according to Section 4451 of the U.S. Tax Code. The U.S. Tax Code, for those of you not familiar, are the reason why most of us angst around April 15th every year, because we're subject to 7,000 plus pages, 2,000 plus sections of this bloated code that has amendments, loopholes, legalese, and all kinds of exemptions. So you can see in this chart that the tax code is 7,000 plus pages, but that's not the full story, because every year the IRS produces a number of tax bulletins, and these bulletins are clarifying. They tell us how we're supposed to interpret the tax code itself. So really the tax code isn't just the tax code, it's the tax code plus all of the clarifications, and that amounts to 80,000 plus pages. And if you look at the growth of those pages projected over time, by 2050, that'll be 140,000. A normal person sitting down to try to read that would take 4.5 years, 8 hours a day. And what a 4.5 years that would be. It's no wonder then that Americans spend $14 billion just to deal with this pain and complexity. Hi, I'm Chris, and I'm going to tell you about how I used AI agents, specifically Google Gemini as the large language model, to rewrite the US tax code down to 40% of its original size in 2 weeks. So in order to do this with a scalpel instead of a hammer, we need to have an understanding of where the complexity lies in the first place in the tax code. And so to accomplish this, I looked at 4 dimensions of the code. First is, for every section, how many bulletins reference it? In other words, how many times has the IRS felt it necessary to clarify a certain section of the code? And the second, how many times has this thing been amended? The more amendments, the more churn. Adds to complexity. And the third is just how long is it? Brevity is the soul of wit, right? And the fourth is the complexity and legalese of the language itself. So those 4 dimensions were measured on every section of the tax code to create a normalized complexity score. And that became guiding. However, understanding the complexity of the tax code is one thing, but there's also parts of our code that are necessary. They might be complicated, but we need them because they're fundamental. For example, early sections of the tax code define some fundamental things like the tax brackets or the percentage that corporations pay. So they might be complicated, but removing them just because they're complicated might not be as surgical as we'd like. So we need another way of thinking about this. This is where I came to impact. The idea of impact is, for every section of the tax code, there's a certain number of people or businesses impacted, and there's a certain overall financial impact of that section. The more impactful something is, the more careful the agent should be about whether or not to make modifications. So this is where Gemini, Google's large language model, was really helpful, because Gemini is multimodal. And what that means is that not only does it interpret text, it can interpret imagery. So I used an agent to look through literally hundreds of pages of tax statistics that were in the form of scanned PDFs to pull the information around impact I needed and make those associations with sections in the tax code. This gave us a 3D map. And this 3D map looks at complexity versus impact on people, businesses, impact in dollars. And it gives us an idea that the low impact, high complexity areas, those are prime targets to either simplify or delete. And the high impact, high complexity, anything high impact, we have to be careful about. And so this became the way that the agent was able to prioritize what sort of action it should take on each section of the code. Once we know that, the agent can make a decision to keep, redraft, simplify, or delete. Okay, this AI agent works iteratively, meaning it'll start with the original tax code, attempt to cut it down by 50%, then take that 50% and attempted to cut it down by another 50%, and so on and so forth. And the reason for that is if we tried to tell the agent to go from the entire 7,000 plus pages of tax to, say, 20 pages, it would probably make some very aggressive, poorly informed decisions. So I like this iterative approach because it allows us to kind of track exactly what's happening every step of the way. So what happened when I ran this thing? Well, interesting. It took two days or so to run. Produced some what I thought were pretty good results. I went through all the data as much as you can with that much data and tried to do different kinds of functional tests to make sure that it worked out. And at a high level, what it did was a lot of rephrasing of archaic tax language and a lot of simplification. About 10% of the sections got deleted. About 15 to 20% of the sections were kept exactly as they are. But there was a lot of wordsmithing to do. And if you go into the actual sections in the tax code and just sort of spot check them, you'll kind of see why. A lot of these were written a long time ago, and they needed some love. In the future, I could see this being general purpose to regulation. I could also see taking a scenario-based approach where you're running simulations, you're changing the goals of the agent based on the legislative changes you're trying to make. And it would be a really interesting way, I think, to model legislation in the future, not just to cut existing legislation. To recap, this project managed to, in 2 weeks' time, compress the size of the tax code by 60%, mostly through a lot of rephrasing and simplification, but a couple hundred deleted sections, a couple of hundred sections that it decided not to touch. And in just a review of the information, it seemed like it did a very nuanced job at making these decisions. Its thinking is recorded and justified for every step that it makes. If anything, I think what this does is it shows the potential of these kinds of tools to tackle some of the big looming regulatory challenges we have at all levels of government. Thanks to Google and Kaggle. I appreciate the GenAI course. I'll leave a link in the description to the GitHub open source project if you want to download the code or the data. Thanks a lot.